Have you ever wondered what's actually going on inside a baby's head? I mean, we know they're learning a ton, but what do they start with? What's the mental hardware that's running right out of the box? Well, today we are diving into a really cool idea that tries to answer exactly that. It's called core knowledge.
You know, for centuries, this has been the big question. Thinkers like John Locke famously pictured the mind as a blank slate, just this single, all-purpose learning machine, ready for experience to write on it. But is that really the whole story? Or do we show up with some pre-installed software?
So, to really get this new idea, we first need to understand the two classic answers that have pretty much dominated this whole debate. Okay, so on one side, you've got this idea that our mind is like one big, powerful, all-purpose computer. It can learn language, math, social rules, you name it, all using the same basic operating system. But then, on the other side, you've got the view that the mind is more like a Swiss Army knife. It's packed with tons and tons of tiny, specialized tools, each one perfectly evolved for one specific job.
But what if both of those are a little bit off? What if we aren't born with one giant machine, or thousands of tiny ones? This is where a third, and I think really elegant, idea comes into play: core knowledge theory.
Core knowledge basically says, hey, let's find a middle path. The idea is that we aren't born with everything, but we're definitely not born with nothing either. Instead, we come equipped with just a small handful of these foundational knowledge systems. They're like the essential starting points, the scaffolding that all of our later, more complex learning gets built on.
And the number here is really the key. We're not talking about one system, and we're not talking about hundreds. Researchers think there are maybe just 5 or 6 of these core toolkits. They're innate, they're specialized, and they give us a massive, massive head start in making sense of the world.
Okay, so that's the theory. To make this a bit more real, let's look at the system that's been studied the most, our core knowledge of objects. You can think of it as our built-in intuitive physics engine that tells us how physical stuff is supposed to work.
What's just wild is that even tiny infants seem to get these rules. They expect objects to be solid things that hold together. They expect them to move smoothly through space, not just blink out of existence and reappear somewhere else. And they expect things to move because something else hit them. And we know this because when scientists run experiments that violate these rules, babies literally stare longer. It's their way of saying, wait a minute, that's not right.
Now here's a really clever part of the theory. It's not just about what these systems can do, but also what they can't. Each one has what scientists call signature limits. Basically, specific situations where the system just breaks down because its rules don't apply.
And this example with sand is just brilliant. Think about it. A pile of sand isn't a solid, cohesive object. So in experiments, if you show a baby one pile of sand going behind a screen and then 2 piles come out the other side, they're not surprised at all. Their core object system, which is great for tracking a toy car, just doesn't know what to do with something like sand. It's outside the system's programming.
All right, so we've got a system for objects, but what other tools are in that starting toolkit we're all born with?
Well, researchers have found evidence for a few others. There seems to be one for number, that gut sense of quantity. A system for agents, which helps us understand that some things, like people and animals, have goals and intentions. There's a system for places, for figuring out how to get around. One for forms, which gives us an intuitive grasp of geometry. And there might even be a system for social partners, helping us quickly figure out who's in our group and who isn't.
So this all sounds pretty fascinating, but you might be asking, does it actually matter in the real world? I mean, can how well a baby's core knowledge works predict anything about their future? The answer is a huge yes, and frankly, it's stunning.
Get this. A major study measured the number sense of 6-month-old babies, basically how good their little core number system was at telling the difference between quantities. Then, they followed up with those same kids 3 years later. The finding was absolutely incredible, that infant number sense actually predicted how well they do on standardized math tests in preschool.
And this is exactly what that finding looks like. The infants who showed a sharper, more accurate number sense at just 6 months old were the very same kids who, years down the line, were scoring higher in math. It really suggests that this early, nonverbal system is a true building block for the symbolic math we learn later on.
And here's the absolute clincher. This connection was still there even after the scientists controlled for general intelligence. So this isn't just about some babies being smarter overall. No, the strength of that one specific core number system was a unique predictor of future math skills, totally separate from their general IQ. How cool is that?
So, what's the big picture here? What's the major takeaway?
Well, this theory gives us a much more detailed picture of how our minds get built, starting with these fundamental building blocks.
Look, core knowledge isn't the whole story, but it's the essential first chapter. We start with these innate foundational systems, and then through experience, through language, through culture, we combine them, we build on top of them, and we create all the incredibly flexible and complex skills we have as adults, everything from calculus to philosophy. These core systems, they're the launch pad.
And that leaves us with a really fascinating thought to end on. If these powerful, ancient systems are the very foundation of how we think, it just makes you wonder, what are the limits of what we can build on top of them? What are we truly capable of?